Have you ever stopped to think about what's really happening when you tap your credit card, or stream a movie, or even just check your bank balance? Behind almost every single thing we do online, there's this silent, incredibly powerful engine managing just unbelievable amounts of information. So today, let's pull back the curtain on this unseen world and demystify the database.
To really get why these systems are so important, let's start with a kind of a scary question. What if your bank, the place with your life savings, managed everything using just a folder full of simple text files? I know, it sounds completely absurd, right? But thinking about that nightmare scenario is the perfect way to understand the exact problem that databases were invented to solve.
Because honestly, trying to store critical data in simple files is just pure chaos. It is totally unsafe, it's incredibly fragile, and it's just asking for all kinds of inconsistencies. I mean, imagine two bank tellers trying to update your account file at the exact same time. Who wins? Or what happens if the power goes out right in the middle of a transaction? That's where a special kind of software comes in. It's called a database management system, or just DBMS for short. And its entire job is to bring order to this chaos. It's organized, it's secure, it's resilient, and maybe most important of all, it is consistent.
So, what exactly is this system that brings order from all that chaos? Well, it's the Database Management System, the DBMS, and you can really think of it as a powerful guardian for your data. Okay, so here's the textbook definition. A DBMS is a software package designed to store and manage a very large, integrated collection of data that models a real-world enterprise. So think a university or a bank or an online store, but really, you should think of it less like a simple filing cabinet and more like a super skilled librarian, a security guard, and a meticulous administrator all rolled into one incredible piece of software.
So, what does this Data Guardian actually promise to do for us? Well, for starters, it promises efficient access and way faster development time for applications. It guarantees, and I mean guarantees, ironclad data integrity and security. It lets tons of users access the data all at once without tripping over each other, and this is a huge one, it can recover from system crashes. Notice how every single one of these promises is a direct solution to a problem from that chaotic world of simple text files we just imagined.
But how? How does it actually do all of this? What's the secret to its power? Well, it all comes down to this really brilliant idea: layers of abstraction.
Okay, let's use a university as an example to see what I mean. As a student, you might go to a website and see a simple page with course info. The course ID and how many people are enrolled. It's clean, it's simple, it's exactly what you need to see.
But if we peel back one layer, we see what the application programmer sees. They don't see that web page, they see the underlying logical structure, what we call the schema. For them, it looks like a set of interconnected tables, a student's table, a courses table, and an enrolled table that links them together. This is where the data gets organized. And then if we go all the way down to the deepest level, the computer itself sees something totally different. It just sees the physical files and indexes that are actually stored on the disk drives. This is the physical schema, the raw, nitty-gritty reality of where all the bits and bytes actually live. And this right here illustrates the core concept perfectly. The university can completely reorganize its hard drives. They can buy new ones. They can change everything about the physical storage. But as long as that logical structure, those tables, stays the same, the application on the website doesn't break. It doesn't even know anything changed. It doesn't care. And that freedom, that separation is called data independence. It is one of the most powerful features of a DBMS.
All right, let's tackle another classic problem. How does a DBMS handle what we call concurrency? I mean, how does it stop two different people from booking the very last seat on an airplane at the exact same millisecond? The answer lies in another really clever concept.
And that concept is called a transaction. A transaction is an atomic, which is just a fancy word for all or nothing, sequence of actions. When you transfer money, that's a transaction. It either happens completely, the money leaves one account and arrives in the other, or it doesn't happen at all. Period. There is no in between.
Let's see this in action because it's pretty cool. Let's say you want to move 50 bucks. First, the system checks if you have the funds. Yep, you do. So it subtracts $50 from your savings. And crucially, it writes a little note about this in a special file called a log. But then, disaster. The system crashes before the money can be added to your checking account. So when it reboots, the very first thing that database does is check that log. It sees, hey, I started a transaction here, but I never finished it. So it just follows its own notes and undoes the subtraction. The $50 is put right back into savings. Your money is completely safe. That's the all-or-nothing promise.
So this technology is obviously incredibly powerful, but it doesn't just run itself. It takes a skilled human expert to design, manage, and protect the whole system.
And that expert is the Database Administrator, or DBA. You can think of them as the captain of the ship. They are responsible for the entire life of the database, from dreaming it up and designing it to making sure it runs perfectly every single day.
And their job is absolutely critical. The DBA designs those logical and physical schemas we were just talking about. They are the ones in charge of security, deciding who gets to see what data and who's allowed to change it. They're responsible for making sure those crash recovery plans are in place and working. And they are constantly tuning the system to make sure it's running as fast and as efficiently as possible.
So when you put all of these pieces together, the structure, the safety, the expert management, you really start to see why this technology isn't just useful, it's fundamental. It's why databases pretty much run our entire modern world.
I mean, let's face it, we are living in an era of just explosive data growth. Every single day, we generate a truly staggering amount of information, from high-level scientific research to the thousands of photos we post online. And all of that data needs a safe, organized home.
And that's why you'll find a DBMS at the heart of nearly everything we do. They power massive scientific efforts like the Human Genome Project. They run all of e-commerce and banking. They serve you videos on demand, and they manage every single post, like, and connection on all our social media platforms. They are the invisible infrastructure of our digital lives.
There's a really powerful idea that sums this all up perfectly. We've witnessed a fundamental shift from computation to information. See, for a long time in computing history, the main challenge was just raw processing power. But today, the much bigger challenge is managing, securing, and making sense of just incomprehensible amounts of information. And that, right there, is the job of the database.
So yeah, it's pretty clear. Our digital world is quite literally built on a foundation of databases. They are the unsung heroes, making sure our data is safe, consistent, and always available. Which leads to one last thought to leave you with. What's the next great challenge, the next big problem that these powerful engines are going to have to evolve to solve?